Hey there, and welcome. Today, we're going to dive into Kubernetes, the powerhouse that's pretty much running the modern internet. You might have heard it called K8s, or maybe you've just seen that cool ship's wheel logo. In the next 5 minutes, we're going to break down what it actually is and why it is such a game changer. Let's get right into it.
But first, let me ask you something. Have you ever stopped to think about why the big apps you use every single day, your streaming services, social media, all those shopping sites, why do they pretty much never crash, even for a second? Well, the answer is actually fascinating.
The secret is managed chaos. Yeah, I know. It sounds a little dramatic, right? But honestly, it's the perfect way to describe the huge problem that Kubernetes was built to solve. And to really get why the solution is so brilliant, you first have to understand the chaos.
So, where does all this chaos come from? Well, it's all because of this massive, radical shift in how we build software. We've gone from building these gigantic, single applications to instead coordinating these huge swarms of tiny little independent services. See, back in the day, applications were what we call monoliths, just these single giant chunks of code. And the problem was, if one little part failed, the whole thing could come crashing down. But now, we do things totally differently with microservices. A modern app is made of hundreds, sometimes thousands, of tiny services, each one running in its own little box called a container, and they all have to work together perfectly. Okay, but this creates a huge new problem. I mean, how on earth do you manage and coordinate and just keep thousands of these little containers up and running across a whole bunch of servers? Trying to do that by hand? Well, it's not just complex, it's pretty much impossible. And that is the chaos. And right into the middle of all this chaos steps our hero, Kubernetes. It's like the conductor of a massive digital orchestra, the master orchestrator that brings perfect harmony and order to all that complexity. Okay, so what is it officially? Kubernetes is an open source platform for something called container orchestration. It was actually born inside Google to handle their own mind-bogglingly huge apps, and its whole reason for being is to automate all the hard parts of running apps that are built with containers. So, what do you actually get with Kubernetes? What does it promise? Well, first up, high availability. That means your app is always on for your users, no downtime. Second, scalability. When a ton of people suddenly start using your app, Kubernetes just adds more resources. Easy. And third, disaster recovery. If a server literally catches fire, Kubernetes automatically fixes the problem. It just self-heals. Okay, that all sounds great, but how in the world does it pull all this off? To get it, we need to look at the core building blocks. We're going to build this up from the smallest piece. All right, it all begins with something called a pod. A pod is the smallest, most basic thing in the entire Kubernetes universe. The best way to think of it is like a little house or a wrapper that holds your actual application container. You don't talk to the container itself, you talk to the pod. But here's the catch, and it's a big one. Pods are ephemeral, which is just a fancy way of saying they're temporary. They can and do disappear all the time. And when a pod dies, Kubernetes is amazing. It instantly creates a brand new one to replace it. But here's the problem. That new pod has a completely different, totally random IP address. And that's exactly why we need something called a service. A service gives you one stable, permanent IP address that never changes, even if the pods behind it are being created and destroyed constantly. It's like having a permanent street address so the other parts of your app always know where to send their messages. Okay, so in the real world, you're not actually messing with individual pods. Instead, you create what's called a deployment. You basically hand Kubernetes a blueprint and say, hey, I want 3 identical copies or replicas of this pod, and I want them running at all times. Kubernetes then takes that blueprint and makes it happen, always working to make sure reality matches what you asked for. Now, this whole blueprint thing, it's perfect for what we call stateless apps, things like a web server where every copy is exactly the same. But what about things that need to remember stuff, like a database? Well, for those stateful apps, Kubernetes has a special kind of blueprint called a stateful set. And that's really the core of it. With a database, you can't just have interchangeable clones. Each one needs its own unique, stable name and identity, so it can keep track of its data properly. It's absolutely crucial for making sure data doesn't get corrupted. All right, so let's zoom out from all these little pieces and look at the whole system, what we call the cluster. A cluster is just a group of servers or nodes, and they basically come in 2 flavors. I like to think of it as the brain and the muscle. You've got the master node, that's the brain. It runs the whole show, makes all the big decisions, and keeps an eye out for trouble. And then you have the worker nodes. They're the muscle, doing all the actual heavy lifting of running your application's pods. So if we peek inside that brain, the master node, you've got a few key players. You've got the API server. That's the front door and the bouncer for any command. You have the scheduler, whose only job is to figure out the best worker node to place a new pod on. There's the controller manager, which is like the ultimate watchdog that's constantly making sure things are okay. And finally, etcd, which is basically the cluster's memory. It knows the state of everything. And this is where that self-healing magic we talked about actually happens. The controller manager, the watchdog, sees that a pod has died. It immediately tells the scheduler, who finds a new, healthy worker node to be its home, and boom, a new pod is created. And this all happens in seconds, automatically, with no person needing to lift a finger. It's incredible. Okay, let's bring it all home. Why does any of this complicated stuff actually matter? Well, it's because this system has become the invisible engine that powers the entire modern internet. You see, the whole point of this entire elaborate system is to achieve unbelievable levels of uptime. Engineers have this goal called 5 nines. That's 99.999% availability. What does that even mean? It means your app is down for less than 6 minutes a year, the whole year. And Kubernetes is what makes that goal a reality. And the crazy part is, you are using Kubernetes every single day, and you probably don't even know it. The video you're streaming, the things in your online shopping cart, that social network you're scrolling through, your food delivery app, it's everywhere. They all rely on this to stay online and handle a massive number of users. I think the source material really nails it when it says, Kubernetes helps you manage applications that are made up of hundreds or maybe thousands of containers. It takes a task that would be an absolute nightmare and makes it automated, resilient, and, well, manageable. So there you have it. Kubernetes is the master conductor of our digital world, the thing that tames the chaos. It really is an amazing piece of engineering. But it kind of makes you wonder, right? As our world gets even more complicated, what's going to orchestrate the orchestrator? Thanks for watching.